reliable device. It mixes air and fuel in the correct ratio for internal combustion of an aeroplane engine. As air is sucked into the engine, firstly it passes through the air filter. It then flows through the carburator's narrow section, called the venturi. At this point, the static air pressure falls and fuel is drawn into the airstream. The mixture enters the engine cylinders for combustion and flows out of the exhaust as hot gas. If you are old enough to have seen a carburator in a motor vehicle, you may be wondering why the aeroplane's carburator is mounted upside down and below the engine. One advantage is to prevent the engine from flooding with excessively rich mixture. Any surplus fuel simply flows down out of the system. Another advantage is that if the carburator was mounted on top of the engine, the pilot would have a good view of it but would not see what's in front of the aeroplane. A typical training aeroplane's carburetor is susceptible to ice forming in the venturi. Ice can restrict the airflow and possibly stop the engine. You don't even need to be flying through a snowstorm for the ice to form. Even on a warm day, if there is moisture in the atmosphere, it can form into ice inside the carburetor. The temperature of the air drops dramatically in the venturi because the static air pressure drops. The air temperature drops some more because fuel that is drawn into the airstream evaporates. Just like the sweat that evaporates off your skin to cool you down, so does the air inside the carburetor. Ice is most likely to form at low engine power. At a low power setting, the carburetor's butterfly valve is nearly closed, which means that the temperature drop is significant because the venturi effect is significant. A low engine power setting also means that the normally hot engine block is cooler. Therefore, the attached carburetor is cooler. These factors combined create the perfect recipe for ice to form. Ice formation in the carburetor can be observed by rough engine running, lowering of the engine power, and subsequently a total engine failure. So how can you prevent carburetor ice from forming, or remove it once it's already formed? The engine's hot gases pass through the heat exchanger before they exit out of the exhaust. By switching carburetor heat on, the airflow is redirected through the heat exchanger where its temperature is raised. The warmer air flowing through the venturi prevents ice from forming, or it can melt ice away if some had already formed. Since hot air is less dense than cold air, the engine power drops when carburetor heat is applied. If ice is present, the engine power will drop initially, then increase considerably once ice is gone. The engine may experience momentary rough running as the melting ice is ingested into the engine. You must apply carburetor heat only as directed by the pilot's operating handbook applicable to your aeroplane type. Generally, carburetor heat is not used on or low to the ground because the heated bypass air is not filtered to remove contaminants from the airflow. Carburetor heat should not be used for extended time as it can overheat the engine and even burn a hole in your exhaust.